So far we have solved the linear differential equation of higher order with real constants. Suppose instead of real constants, if you have variable constants, means linear differential equation with variable coefficients, then what type of method we will use to solve this type of differential equation? The method is method of variation of parameters. We can solve the linear differential equation of second order with variable coefficients. Method of variation of parameters means the general form of the linear differential equation of second order is d square y by dx square plus p of x into dy by dx. This is p of x, this is variable coefficient. P of x into dy by dx plus q of x into y equals to r of x. This is nothing but linear differential equation of second order with variable coefficients p of x and q of x. R of x is a function. These three functions are continuous functions: p of x, q of x and r of x. Then if you have this type of differential equation, when you are solving by method of variation of parameters, means if they told solve the differential equation by method of variation of parameters, then only you have to use this method. Means if you once you confirm this is linear differential equation with variable coefficients, then you have to apply this method. There is no other method to solve the differential equation. To solve this differential equation, consider the complementary function for this one. Yc equals to, the general solution for this differential equation is every time y equal to yc plus yp. Yc is nothing but complementary function, yp is nothing but particular integral. Yc equals to, consider directly c1 u of x plus c2 v of x. Then how to calculate this u of x and v of x? Well, while solving the problems, we can get very clearly, nothing is there, simply the same technique, r of x equal to 0. RHS side, if you are putting 0, then automatically you will get the complementary function by using previous methods. Means we are taking specially here by method of variation of parameter, yc equals to c1 u of x plus c2 v of x. This is over. Now particular integral yp equals to formula a into u of x, capital A into u of x plus capital B into v of x. Now you calculate here capital A and capital B separately. For that one, capital A equal to integral v r dx by u v dash minus v u dash. This is the formula, A formula, capital A formula. Integral v r dx by u v dash minus v u dash. And capital B equals to minus u r dx by u v dash minus v u dash. Now like this we can calculate the particular integral and complementary function. After calculating complementary function and particular integral, the general solution of the linear differential equation of second order by method of variation of parameter, the answer is y equal to yc plus yp. Means in different way we are calculating complementary function and particular integral here for this method of variation of parameters. Now this is very very important. Many times he asked the question on method of variation of parameters. This is most important.